Okay, so we're looking at situations where we have two variables and we want to show if there's a relationship between the two variables. And one of the best ways to do that is via a scatter plot. And so we graph the data and get a series of points, and we look for any patterns within those points. And we describe those patterns with three different descriptions. The first one is the strength, if it's a moderate, strong, or weak relationship. Direction being positive or negative, and the form of the relationship, usually linear or something that's not linear, i.e. a curve. Okay, linear relationships are what we're going to start out looking at, and they are most important because it's a straight line, it's a simple pattern, and it does happen a lot in real life. Okay, unfortunately, we can't always trust our eyes and looking at a scatter plot and determining how strong a line is that goes through the middle of all the points. So we've come up with a mathematical way of describing this through what is called the correlation coefficient, which is abbreviated R. It measures the strength of the linear relationship. R is always a number between -1 and 1. If R is positive, it means that there's a positive association. If R happens to be negative, then it indicates a negative association. So a positive association would be something where if I were to connect the points, I would get something that increases, where a negative association would be something where if I connect it would be going down. If you get an R value close to 0, that indicates a very weak relationship. And the strength of the linear relationship increases as R moves away from 0, either towards -1 if it's a negative relationship, or to +1. Real life, you never get correlation coefficients exactly -1 or exactly 1, but if you were, that would occur when the points lie exactly along a line, and there is absolutely no variation from that or deviation from there. So R is a way to measure the strength component of a linear relationship. So let's take a look at some scatter plots and see if we can figure out what kind of R value is associated with each. So here's an example of a scatter plot in which I really don't see much of a relationship there. I'm not sure which way to draw the line. The points are scattered all over the place, and it's really hard to tell where I would draw the line and in which direction. So this would be an R value of actually 0. A very weak relationship, scattered all over the place, no direction whatsoever. Okay, so let's take a look at this one now. This one a little bit stronger. I can start to see, especially with this point down here, that maybe there's a little bit of a relationship, a linear relationship down going this way. But again, this is a very weak relationship. This is not something that I would look at and say I'm real confident in. Okay, so while there's a little bit of a relationship, a little bit more in the other one, certainly this is not a very strong relationship. In fact, this would be considered a weak relationship. And this has an R value of -0.3. So as you can see, fairly close to 0. Okay, so if we take a look at this one, now here's a relationship that I can definitely tell that the relationship would go high. Again, it's not real strong. It's still scattered around those points. But again, it's a little bit stronger. I have a bit more confidence that relationship is going positive. And because of that, I do expect to see an R value that is positive. And sure enough here, this is an R value of 0.5. This would be a moderate one. It's not strong, it's not weak, but it definitely is positive. So let's take a look at this one. And you can see here, now this is actually starting to get even stronger now. The points are settling in on that line. So when I draw the line that goes through the middle of this, there's not as much variation as I saw in the last one. There's still some. It's still not a perfect fit. And again, it's negative. It's going down. So this would have a R value of, say, something like -0.7. Again, getting moderately strong now. Okay, so it's not weak, obviously. It's not moderate, but moderately strong. Okay, so let's take a look at the next one here. Now you can see here the relationship's really getting strong. Again, this is a positive relationship, but again, the points are not scattered about the line nearly as much as we've seen in the part of the previous one. So this is a very strong relationship. Certainly not perfect, but it certainly is better than the ones we've seen. So this was the reason this gets an R value of 0.9. A very, very strong relationship. Okay, and that last one here, here's another one that is very strong. Again, it is negative, it is going down, And you can see that when I draw the line through the middle, there's not much variation. Most of the points are surrounding that line and very, very tightly surrounding the line. So again, this would be a very strong relationship, and this would have an R value actually of negative 0.99, very close to negative 1, not perfect, but certainly a very strong line. So when we draw those lines of best fit that kind of goes through the middle of that, this is called a linear regression. And a regression line is a line of best fit. Some of you may have known that from previous courses. But it is a line that goes through the middle of all the points. And we're actually going to learn how to calculate that exactly. Determine how good a line is, you always have to look at the correlation coefficient R. Reminder, this will always be a value between negative 1 and 1. Negative 1 being a perfect negative relationship, positive 1 being a perfect positive relationship, and 0 being absolutely no relationship at all. A very weak one. Okay? So as a reminder, we describe a linear regression equation using those same descriptions that we use for a scatter plot. Form being linear, or possibly could be something else, like a curve. Direction, positive if it's increasing, or negative if it's decreasing. And strength, being strong, if we see a correlation coefficient, 0.8, 0.9, that would be considered pretty strong. Moderate would be something in the 0.4, 0.5, 0.6, 0.7 range. And weak would be numbers less than that, 0.1, 0.2, 0.3. Okay? And 0 would obviously be if we cannot see any relationship at all, not even sure which way to draw the line. So once again, we describe a linear regression equation in the same way that we describe a scatter plot. As we look at linear regressions, there are two values that become important to us. The first one, as we talked about before, is R, is that correlation coefficient. However, it does not take into account the difference between the explanatory and response variable. Okay, and basically R measures how close the data points are to one another. Okay, that's what R measures. There's another number that helps us describe a line, which is called R squared. And R squared determines how well the data actually fits the line. So in other words, once a line is drawn, R squared tells me how close those points are to the line. Okay, so it's really important that you understand the difference between that. R measures how close the points are to one another. In other words, how close you could draw a line there. A line's not drawn yet. Where R squared actually measures how well the points are to a line that is already drawn there. So big difference between R and R squared. R squared does however, depend on the distinction between explanatory and response variable. It is very important that you interpret R squared where the explanatory variable is on the x-axis and the response variable is on the y-axis. Where R does not require that. You can still show a correlation no matter which variable is on which axis. So we will take a look at further look at linear regressions and get a better feel for this as we continue on in this chapter. Please continue to take notes on the worksheet that's provided for you on the website.